All right, dear students, in this video tutorial, I will be explaining you the practice questions from the slides. First of all, let's take a look at the question number one. Like basically, it says calculate how many hydrogens atoms are present in these. We have three choices. So let's see how do we do these questions. Whenever I see a stoichiometry question, I always take a look at these. Always remember this. First of all, just know that 1 mole of any entity. What do I mean by entity? It can be molecule, ion, atom, proton, or electron, etc. So 1 mole, whenever we change from mole to these, n of these, we have to multiply by 6.02 times 10 to power 23. Okay, also make sure to, let's do one example and let's see how it works. So 1 mole of hydrogen. How many hydrogen molecules we have in 1 mole of hydrogen? You see, we are changing from mole to molecule, so we have to multiply by 6.02. Let's write 1 times 6.02 times 10 to the power 23. But whenever it asks regarding individual atoms, always take a look at, does it ask for atom or does it ask for molecule or ions? If it is an atom or an ion, we have to consider this subscript. So in one hydrogen, in just one hydrogen molecule, we have two hydrogen atoms, yes? Whenever we change from mole to atoms, first of all, we have to multiply, by the way, sorry, this is not 2 mole, this is 1 times 2.6.02, then times 2. It's better to write it like that. So if it's 1 mole, so 1 times 6.02 times 10 to the power 23. And because it's an atom, we have to at the end multiply by 2 times 2. It's a better version to write it. Also remember that whenever we change from mole to mass, what do we use? We always use the periodic table. Okay, let's take a look at this example. 1 mole of hydrogen, how do we find the mass of it? We take a look at the periodic table. Hydrogen is 1, 1. So what will happen? The mass is 1 mole is 1 gram, so per mole. So molar mass is that 1 mole is 1 gram. Let's make it a capital M, so this represents a molar mass. So and this is H2, yes. So 1H mass is 1 gram, so 2H will be 2 grams. And whenever it's about the gases, also the condition, whenever you see the condition of STP, always remember this 1 mole is 22.4 liters. Remember these few information. Also, I highly encourage you to remember two formulas. N is equal to N divided by NA. Also, N is equal to M divided by capital M. Na, Avogadro's number. 6.02 times 10 to the power 23. M is molar mass, and molar mass we use periodic table to find it. So let's do calculation number one. How do we find the number of hydrogen atoms? In the question, if it asks for the amount of atoms, so what did I say? We have to consider what? These 5 and 1. So we can, we have how many hydrogens in one molecule? 6 hydrogen, yes? Please consider that. So let's use this method first. So let's find out how many molecules do we have. N is equal to N divided by Na. We know small n represents mole. So 0.02 is equal to our n molecules we don't know. Our Na is 6.02 times 10 to the power 23. So we can find from our number of molecules of ethanol C2H5 from here. So it will be 0.02 times 6.02 times 10 to the power 23. We use the formula, we find the N for C2H5OH, but as it's asking for specific hydrogen atoms, we have to make sure that we have to multiply at 6 at the end, as we did in this example. You see, it was asking hydrogen atoms. I included this superscript. Any questions? So the answer will be 0.02 times 6.02 times 10 to the power 23 times 6. The correct answer should be provided in here. The answer would be 7.2 times 10 to the power 23. If you do question number 2, again, this is easier. So we should write n is equal to n divided by na. So we can find the formula. 2.5 is equal to n divided by, what's our Avogadro's number? 6.02 times 10 to the power 23. So we can find how many water molecule we have. It will be 2.5 times 6.02 times 10 to the power 23. And at the end, if it asks hydrogen atoms, what we should multiply, we have to include this. So times 2, and we should get the answer. And just for you to know, whenever there is a parenthesis, these 2 is for all of these 3 elements. So we have 2 hydrogen in here, 2 carbon in here, and 6 oxygen in here. So whatever we find, this is 0.1 mole, yes? So it will be 0.1 times 6.02 times 10 to the power 23 using this formula. At the end, how much we should multiply? We have to multiply by 2 because in 1 we have 2 hydrogens. Any questions? Hopefully you got the idea. Let's take a look at question number 2. It says propane has the formula of C3H8. So C3H8, meaning that we have 3 moles carbon and we have 8 moles hydrogen. Let's take it like that. It says if we had a 0.2 moles of carbon, 0.2 moles of carbon will be how many hydrogens? Let's write X moles of hydrogen. I can easily put this because this is 3 carbon, 8 hydrogen. I put it like that. You know the double arrow method. So the answer will be 8 times 2x will be 8 times 0.2 divided by 3. Let's quickly calculate it. 8 times 0.2 divided by 3. The answer should be 0.53, etc. So let's check the question. 0.53 moles of hydrogen. And coming to the last question. It says calculate the amount of sulfuric acid which contains 6.02 times 10 to the power 23 numbers of atoms of oxygen. So this is the opposite of question number 1. So we can do this double arrow method, or we can do the formula method. If we use a double arrow method, it says calculate the amount of sulfuric acid. I can write X mole because amount is mole. If it contains 6.02 times 10 to the power 23 atoms oxygen, let me write sulfuric acid, H2SO4. So what we should have below atoms of oxygen, of course, we should have atoms of oxygen. What should we have below moles of H2SO4? We should have moles of H2SO4. Remember that we have to have always the same units below in the same column. So how many moles is easier to work with? Of course, 1 mole. By the way, one side is the question side, another side is the side that we should know. In 1 mole of H2SO4, how many molecules of H2SO4? We know that we have the 1 multiplied by 6.02 times 10 to the power 23. Remember, whenever we change from mole to atoms of oxygen, atoms, we have to consider this subscript. So we have to be multiplying by 4. So x would be equal to 1 times 6.02 times 10 to the power 23 times 4 divided by this times this. Okay, divide by 6.02 times 10 to the power 23. So these cancel each out. And at the end, we are getting, I believe, 4. Let me see, where did we make a mistake? Oh, sorry, x times. Okay, this one is at the bottom. Sorry. We have to do correct cross multiplication method. So this times this is equal to this times this. So this will be in the denominator and this will be in the numerator. So now it makes sense. It will be 1 divided by 4 and it gives us 0.25. Okay. Hope that you got the idea of how do we change from mole to molecule, molecule to atom. Remember, whenever we convert it to the atoms or ions, we have to multiply by their subscript. Thank you for listening.